Hello everybody, welcome back. In the last video we talked about geometric sequences and what that looked like. Now we're going to talk about this series. How can we take a sequence of numbers that's geometric and add them together? How can we do that really quickly using a new formula? So last time we learned about a geometric sequence, again, is made by multiplying the same number from term to term, and that number that we're multiplying is called the ratio, and we label it with an R. We played a little bit with our brand new formula that we learned to find any term in a geometric sequence using a sub n, a1, and r. We decided to skip over this idea of puzzle pieces just because it's a little bit tricky, and just for the sake of time, we're going to skip that for now. But let's move on. Now, if I'm giving you a geometric sequence where I add all the terms together, we're going to call that a geometric series. And it's much easier to add those terms together if he is ending, which means if he is finite. So if we do have a finite geometric series and we want to add it really quickly, especially if it's something like 100 or 1,000 terms, we don't want to do it by hand, here's a brand new formula for you too. All right, if I give you, I want to add n terms together, whether it's 100 terms or 1,000 terms, the sum here is s for sum, s subscript n, for n terms, equals, all right, we take the first term, a sub 1, we multiply by, in parentheses, 1 minus the ratio to the n power. And again, n is also the same number of terms. And then we divide on the bottom by 1 minus r. R again is the ratio. So I have all the important abbreviations down here labeled for you if you need them. Now it does look like, doesn't it, that I can sort of maybe do this mathematically and cancel. But unfortunately, I can't do that because if you notice, the 1 minus r on top has an n attached to that r. So because of that, I cannot cancel. I have to leave it just as it is. So don't be too tempted. All right, here's how we're going to play. Let's just try number 3 right here on the bottom. Can you find for me, friends, the sum of the first 10 terms of this given geometric series? All right, well, so far I've got 1, 2, 3, 4 of them. Now I can just write out the next 6 terms and add them if I want by hand, but that's not the point. We want to use the formula to find a fast way. All right, so we're going to need a sub 1, which I think we can find right there. We are going to need r, figure out what its ratio is, and we have n right here. We know it's going to be 10 terms, so we know n is going to be 10. All right, can you take a look at that, friends? What's the ratio from term to term? What am I multiplying by? If you said 3, proud of you. If you said negative 3, I'm really proud of you because you see it alternates positive, negative. So my ratio here is negative 3. All right, well, let's try. Let's see. This is going to be s for sum. Subscript is n, and n here is 10, so we have s sub 10. All right, what's the sum of the first 10 terms of this geometric series? A sub 1 is your first term, which is 2. In parentheses, we have 1 minus an r. If you remember, r was negative 3. Now, just to be on the safe side, I'm going to put r in parentheses. So much so that I think over here in the formula upstairs, I'm going to put r here in parentheses as well. Just because I'm subtracting here, and I'm going to write an exponent in just a second, because I know n is equal to 10. Then I'm just worried I'm going to put that in the calculator in a weird way. So a good hint is always put parentheses around your r ratio. Just mathematically helps. And then we change then and divide by 1 minus, and my ratio here is negative 3, so I should put that in parentheses too, just so I can see the negative. All right, time to simplify a little bit here. All right, I've got 2. 1 minus, now I can't multiply that negative in, as tempting as it is, because the negative 3 is being raised to a power, so order of operations prevents us from doing that. Divide by, well, I can do 1 minus a minus, I know that's plus, so I get 1 plus 3 is 4. Okay, now, time to put this in the calculator. Ready? Let's do steps here. What I would do here, friends, is I would do this part here first. Why don't you take negative 3 in parentheses and raise it to the 10th power. After you do that, why don't you take this part here and do 1 minus, and the best thing is just use your answer button, because then you could store the answer really easily and computes that. So 1 minus your answer button, and then hit enter. And then I would multiply that answer by 2. And then lastly, is here on the bottom, I would divide my final answer by 4. Okay, let's put that in my calculator and I'll see how I do. So as I said, I'm going to take -3 and raise it to the 10 power. Okay, that gave me 59,049. Now I'm going to do 1 minus my answer button. Okay, now when I do 1 minus my answer button, I get -59,048. I'm going to multiply that answer by 2, and I'm going to divide that answer by 4. And my total sum, S sub 10 here, is -29,524. And that's your answer, friends. Now it's negative. Why is it negative? Well, I'm looking at my answer, and I look at the original series here. I'm taking a positive number, subtracting a bigger number, adding a bigger number, but then subtracting another bigger number. So if I do this over and over, I'm going to either add a big positive number or take away an even bigger number. So this kind of makes sense. As I add this all together, I'm probably going to have more negatives. So therefore, I get a negative number when I'm done. And that's a good introduction to how do you do a geometric series that's finite. There's our formula. But unlike arithmetic series, we can actually find the sum of an infinite one if it goes on forever, which seems impossible. How can you add an infinite number of terms? Mr. Brown's going crazy. Trust me, it's actually okay. But 3 rules need to apply here. In order to do this, you have to make sure 3 things are happening. First of all, is your series that you're trying to add up, is it geometric? Okay. Is the series that you're trying to add, is it an infinite series? Remember how we checked that? With the dots. And lastly, here's the really important one. I'll put it in red. Is your ratio small enough? And when I say small, that means my ratio has to be between 2 really important numbers. It has to be less than 1 and greater than -1. Meaning it has to be a pretty small fraction. If the ratio is bigger than that, then the series what's called diverges, meaning it doesn't have a final sum. So we can't do it. So make sure you go through these 3 little checklists here, folks. Is your series that you're trying to add, is it geometric? Good. Is the series infinite, ... and is your ratio small enough? And if it's not small enough, then he diverges and we can't answer it. But if he is small enough, we can find it. And if he is small enough, here's your formula over here, friends. This is the sum. Now notice this is S, but there's no little subscript here. And that's because, how many terms are we adding? Oh, infinite, right? So actually some textbooks will put S with a subscript of infinity, but no, you don't have to. But that's the reason why you don't see anything, is because this is an infinite sum, so we don't need to put it. All right, look at the formula. You have your first term on top, and the bottom is 1 minus the ratio. And that's it. That's all the formula says. That's pretty easy. I love this formula. All right, ready? Shall we try it? Let's try number 1. Let's try to find the sum of this series if it's possible. Now right away, I see the ... so I'm like, oh, I hope this is geometric, because if this is arithmetic, I cannot do it if it's infinite. I can only do finites. So let's do the checklist. Ready? Is it, oh no, let's clear my checklist over here on the right, folks. Okay, is my series geometric? Ooh, that's a good point. I didn't say, so let's see. From term to term, what am I, if anything, multiplying by every term? And it looks like I'm multiplying by, it looks like 1 over 3. But do you notice I'm actually changing the sign? So I'm actually multiplying by -1 over 3. All right, that's my ratio. So, oh, okay, so he's got a ratio, so he's definitely geometric. Is he infinite? You betcha, ... And is the ratio between -1 and 1? Well, you found the ratio was -1/3, which is between -1 and 1. So this works. We can do it. All right, let's try to add. Okay, our formula says S equals A sub 1. A sub 1 is our first term right here, 1, over 1 minus the ratio. And the ratio you found over here is, maybe in parentheses to help, -1 over 3. little bit simplifying. If I do a common denominator 2, that's eventually going to be a positive 4 over 3. And you multiply by the reciprocal and you get 3 over 4. Final answer. So we can do it. I think it's because if you look as I go from term to term, do you notice that because of the ratio being small enough, each term is getting smaller and smaller and smaller, and it's probably getting really, really close to, or really, really close to 0. So I can really anticipate what it's going to equal when I add them all together as it gets smaller and smaller, and it will be 3 over 4. All right, can we try number 2? Number 2 here says, find the sum of the series. So let's do our checklist again. I'll clear it off on the right-hand side here. All right, is he geometric? Let's see, from term to term, what am I multiplying by, if anything? It looks like it's doubling. So I think here my ratio is probably equal to 2. All right, that's great. So definitely geometric. Is he infinite? I see dot, 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 so yes. Now, is my ratio small enough? Is my ratio between -1 and 1? Look and see what we found. It's equal to 2. No, it's too big. So can we find the sum? Not possible. No way. And again, just a little bit of common sense. If you think about it, you're going to keep trying to add these numbers together. Look what's happening to them. Because the ratio is too big, do you see that these numbers are just going to get bigger and bigger and bigger? So if you're going to try to add an infinite number of them, the whole sum is probably just going to be infinite. This is a great example of it just not being possible because your ratio was too big. There you go, folks. That's how you find the sum of both a finite geometric series and an infinite geometric series. Great job.